Let's dive right into this explainer because today we are solving a very common, honestly kind of spooky everyday mystery, that sudden frightening noise coming from inside your plumbing. We're going to figure out exactly why it happens and, more importantly, how you can stop it for good. Picture this. It's late, the house is dead quiet. You turn off the bathroom sink and bam, a loud, sharp banging echoes from right behind the drywall. It literally sounds like there's a ghost with a mallet in there. Most of us, we just ignore it. We blame it on the house settling or maybe just quirky old pipes. But actually, that sound is a very specific physical event, and it's trying to communicate directly with you. And we absolutely cannot just ignore it. That noise, it's a warning. Think about it. If a force is violent enough to physically shake heavy metal or PVC pipes so hard that they're banging against wooden studs, imagine what it's doing to your soldered joints and threaded fittings. If you leave it unchecked, this daily, repeated trauma is eventually going to pull things apart and lead to some pretty catastrophic water leaks. No one wants that. So let's officially identify our culprit here. It's called water hammer, and it happens because the incredible momentum of flowing water is forced to stop abruptly. See, when water travels through your pipes, it has real mass and momentum. It's heavy. When a valve closes instantly, all of that fast-moving water still has to go somewhere, but suddenly its path is totally blocked. And because water doesn't compress very well at all, that forward energy violently transforms into a massive pressure spike. That spike becomes a literal shockwave that aggressively travels backward through your plumbing. And that shockwave is the water hammer. To really picture this, contrast what happens normally with what happens during a water hammer. Under normal conditions, water flows smoothly. Its energy is perfectly directed right out of the faucet or into your washing machine. Everything's in harmony. But when that flow is suddenly interrupted, that abrupt stop acts like a brick wall. The water crashes into the closed valve, and again, since it can't compress, that kinetic energy violently rebounds. It bounces back and forth through the piping. It's that rapid, rebounding kinetic energy that causes the physical vibration and that unmistakable, loud thudding sound. Now, the severity of this shockwave isn't going to be the exact same in every single house. It's actually driven by three really critical factors. First up is the speed of the valve closing. An instant shutoff creates a way sharper spike than a slow, gradual close. Second is the length and diameter of the pipe run itself. A longer run holds more water, which means there's a lot more heavy mass and momentum being brought to an abrupt stop. And third, your baseline water pressure. If your incoming city water pressure is already sky high, the resulting surge from a quick close is going to be significantly harsher. So the most crucial thing we need to do is figure out exactly which everyday appliances or fixtures are acting as the triggers. It rarely ever happens everywhere in the house all at once. Usually, whether you're in an older home or even a brand new build with really tight fittings, specific fixtures are the catalyst for the shockwave. If we can identify those triggers, we've taken the first big step toward a real, targeted solution. Let's look at the usual suspects. Quick closing modern faucets, abrupt toilet valves, and the rapid fill and drain cycles of your dishwasher or washing machine are by far the most frequent offenders. Modern faucets, for example, often have those single lever designs that you can just snap shut instantly, totally different from the old twist knobs that literally forced you to close them gradually. Toilets are another major one. When the tank fills up, that internal float valve often just snaps shut with zero warning. Then you've got your automated appliances. Washers and dishwashers use solenoid valves that electronically snap open and shut in a fraction of a second. Even sudden changes in your water heater's demand can sometimes alter flow patterns enough to set off a shockwave. Here is your ultimate detective tip. Water hammer is almost never random. Repeatability is the key to pinpointing the guilty fixture. If you notice that the walls only bang exactly 3 seconds after you flush the downstairs half bath, or right when the washing machine finishes its fill cycle, boom, you've just found your culprit. That consistency is exactly what allows you to isolate the specific valve behavior that's causing the pressure surge. All right, so how do we fix it? To successfully close this case, our main goal is to either slow down the water's rate of stoppage or give that intense pressure spike a safe place to dissipate. Look, we can't change the laws of physics. Moving water is always going to have momentum, but we can change how your plumbing system handles that momentum. The fix basically requires giving that kinetic energy a cushion so it doesn't have to violently shake your pipes to disperse. Here is your 4-step action plan to tackle this. Step 1. Install a water hammer arrestor. These are brilliant little devices. They contain a small air bladder or a piston, and when the pressure spike hits, the arrestor compresses. It absorbs the shock right near the fixture so it never even travels into your walls. Step 2 addresses the whole house, and that's using a pressure-reducing valve, or PRV. If your incoming city pressure is just too high to begin with, a PRV lowers that baseline, making any surges way less intense. Step 3 is right at the source. Swap out quick-closing parts, like replace the harsh toilet fill valve with a quiet model that's actually designed to shut off gradually. And finally, step 4. Check your pipe supports. Making sure your pipes are securely anchored might not stop the pressure spike itself, but it totally prevents the pipes from physically rattling against the framing, which dramatically reduces the noise. But what if you've tried all the basics and your walls are still banging? Sometimes a DIY fix just isn't quite enough. If you've got recurring shocks happening across multiple different fixtures, or you suspect your incoming pressure is way off the charts, or you just know you have older, deteriorating pipes, it's definitely time to bring in a licensed pro. They can properly measure your whole house pressure and safely solder in heavy-duty arrestors behind the walls before you accidentally cause a pipe blowout. Ultimately, addressing this issue promptly is vital. That banging isn't just an annoyance you have to live with. It is a clear sign of a mechanical mismatch in your home. The speed at which your fixtures are controlling the water is directly fighting your supply pressure. Realigning that balance is really the only way to protect the integrity of your entire plumbing infrastructure. So now that you're armed with the physics behind the noise, it's time to do a little sleuthing of your own. The next time your house goes bang in the middle of a wash cycle, ask yourself, is this just a minor nuisance, or is my home trying to warn me that it's slowly breaking itself apart from the inside? Listen to your pipes, find the repeatability, and quiet the storm behind your drywall. Thanks for joining me for this explainer.